Chapter 7 deals with hypothesis testing, and I have found that if I keep it in a series of steps, this is actually a fairly easy process. And so I'm going to go through the steps that I use when I'm doing hypothesis testing. Please make sure you have read this section thoroughly before you watch the video so that it makes more sense. First test I'm going to do is write the hypothesis statements. And when you write those, you're going to have a null hypothesis and an alternate hypothesis. H0 has to have the equality in it, so you'll see equal, greater than or equal, or less than or equal. HA, or the alternative hypothesis, will have the inequality, and it will be not equal to, less than, or greater than. These come in matched sets. So if H0 is equal to, HA has to be not equal to. If H0 is greater than or equal to, HA has to be less than. If this is less than or equal to, this one has to be greater than. Between the two of them, they have to cover all the realm of possibilities. And this can get a bit tricky in writing your statements, but on page 357, they have a little chart that might help you out with the wording. When they get to, it's less than this, or it's greater than this, or at least, those get a little bit tricky, and that might help you out in figuring which one you're going to be listing out. Identify which one is the claim. One of these, and it can be either one, will be the claim that you're actually testing. And so make sure you write that beside your hypothesis statement right at the beginning. So when you get down to the end, you know whether you're supporting the claim or not. Draw your curve and shade in the tail. So you'll be drawing in a normal curve, a t-curve, or a chi-square curve, and shade in the tail according to your alternate hypothesis. If it's not equal to, it'll be two-tailed. If it's less than, it's left-tailed. Notice it points to the left, and that'll give you a good indication that, yeah, you're going to be shading that left side of the curve. If it points to the right, as in the greater than, it'll be a right-tailed test. Identify your critical value and rejection region. If you are looking for a Z for a critical value, if it's a mean and you have a large sample, or if it's a proportion, you'll be using Z. And you can either look that up on the normal chart or use your inverse norm function to find your Z-score. Your t-value, you'll have to be looking up on the chart, and the same with the chi-square. Just be aware that now you're going to be dealing with different types. So two-tailed, which will be the same results as your confidence intervals, because confidence intervals naturally have two tails. Or it could be a left-tailed or a right-tailed. Your t-chart only gives positive values. So if you have a left-tailed test, you have to know to make that t critical value negative. If it's a right-tailed test, it'll be positive. Your chi-squares are always positive, so you don't have to worry about that there. Step 5. Calculate your p-value and your standardized test statistic. Your calculator is going to do all of this for you except for on the chi-square. There you're going to have to do it by hand. Put your test statistic on your drawing. Put it right on that curve that you made up here in step 3. And if it's in that rejection zone, that means you're going to reject the null. If it's out in the tail, then, I'm sorry, I misstated that. If it's in the tail, you will reject the null. If it is not in the tail, if it is in that H0 area, you will not reject the null. And the last step give a summary in terms of the claim, so that if you are rejecting the null, in other words, you're saying this statement, I'm not supporting that, that means I am going with this HA. If that's my claim, I support the claim. So always go back and make sure that you are giving your summary in terms of the claim that they stated at the very beginning.